This is day 179. Your cells are begging you to move. Disclaimer: don't ever listen to me for what I'm saying or what I'm writing for medical advice. It's a bad idea. Most advice about physical activity focuses on the outside: losing weight, looking better, building muscle. But if you could peek inside your body, deep down to the cellular level, then you'd find a far more powerful reason for you to get up off the couch and move. It's called ATP, and your life literally depends on it. A morning thought. I woke up this morning and wandered into the kitchen. I was considering what to eat, but the only options required some level of preparation. That discouraged me because I was hoping for something easy and simple. The thought of doing work to produce food felt daunting. Of course, a few moments later, it wasn't that bad at all. I had managed to prepare a healthy morning meal, and it really didn't take that long. While eating, I found myself wondering, what exactly is a calorie? I'd never really given it much thought. I had a vague sense that calories come from food and that different types of food contain different amounts. For example, fat has more calories than carbohydrates or protein. So where do calories come from? So I started digging into this with some little bit of research, and as with many words today, calorie no longer means what it once meant. And you have to go back quite a long way to find its origin. The term was first introduced by Nicholas Clement in 1824, during his work on heat energy and thermodynamics. He borrowed the word from the Latin word calor, which means heat. Technically, we're not really talking about calories, but we're talking about kilocalories, or kcals for short. A kilocalorie is the amount of energy required to raise the temperature of a kilogram of water by 1 degree Celsius. The method of measurement is fascinating. You basically take a small amount of fuel, place it in a sealed container called a bomb, and submerge it in water. You then ignite this fuel and measure the temperature increase of the water. The energy needed to raise the temperature by 1 degree represents what we call a kilocalorie, or what we now simply call a calorie. So, how do we get from fire to food? In the 1890s, Wilbur Atwater applied this method to food. He burned food to measure the heat it released and connected this to how the human body metabolizes nutrients. He developed what is called the Atwater system, which is still in use today. 4 kcals per gram of carbohydrate, 4 kcals per gram of protein, and 9 kcals per gram of fat. So the number that haunts you when you eat a donut is actually the result of burning sugar and seeing how much heat it could generate. This got me to thinking, how does this heat measurement translate into what the body does with food? My body isn't heating up water, or is it? Well, not exactly, but the body does use the energy from food for essential functions: muscle contractions, brain activity, repairing cells, maintaining your body temperature. So what's my body doing with this energy anyway? Food is fuel, that much is clear, but how does that translate into cellular function? Why do we use calorie as the unit of measurement? What exactly is happening in the body that uses this fuel? I had a general idea. Digestion breaks food into base molecules like glucose, fatty acids, and amino acids, which are then transported through the bloodstream. But that just seems too simple. I wanted to understand the deeper connection to grasp the impact of a single calorie on my body. Now, I failed biology in high school, and I avoided it in college. I only remember 2 things from my biology class. 1, this annoying girl who sat next to me and constantly popped her gum bubbles. And 2, the word mitochondria. We had to memorize a ton of vocabulary, but that one word stuck with me. Turns out, mitochondria is central to this entire story. So enter ATP, the fuel for life. The human body is astonishingly complex, more so than we can truly comprehend. Yes, the digestive process breaks food down and extracts energy sources. But what really matters is what happens next. It's called cellular respiration. This is the process that converts glucose, fats, and proteins effectively into ATP, which I think the name is adenosine triphosphate. The triphosphate is what's important here. ATP is the molecule fuel your cells use for virtually everything they do. So how does this work? ATP is made up of three components: adenine, which is a nitrogen base that's similar to what we find in DNA, ribose, which is a 5-carbon sugar, and 3 phosphate groups. The phosphate groups are bonded together with high-energy bonds that are unstable due to their negative charges. Imagine trying to push two magnets together with the same pole. They will resist. But if you force them together and then let go, they fly apart. That's effectively ATP. When one phosphate group breaks off, energy is released. Incredible, right? Every time you move your fingers, type a word, blink your eyes, ATP bonds are breaking to release energy. But ATP doesn't just get used up and disappear, it's actually recycled. When ATP loses a phosphate, it becomes ADP, adenosine diphosphate. The mitochondria then reattach another phosphate group to turn ADP back into ATP. So effectively, ATP is renewable, sort of. Your body is an ATP recycling machine. You process somewhere between 80 and 100 pounds of ATP per day. It's incredible. Yet you only store about 50 grams of ATP at any given moment. That means each molecule is reused hundreds and hundreds of thousands of times per day. Are you still wondering why you need food? Because turning ADP back into ATP takes energy. Food is the charger that powers this ATP renewable cycle. Without it, your cells just can't recharge, and the system shuts down. So how much ATP is created from a single carb, which is about 4 calories? On average, one molecule of glucose can produce 36 to 38 molecules of ATP. When you eat that 30-gram carbohydrate donut, you're introducing about 100 sextillion glucose molecules into your system. These are converted into roughly 3.6 septillion molecules of ATP. You don't know what sextillion and septillion are? Go look it up on Google. They're very, very long numbers. This sounds impressive, right? Sure, it is. But put that into perspective. Your body has around 37 trillion cells. Each one of those cells uses up to 2 billion ATP molecules every second. Yes, every second. So, let's get to the power of movement. This brings me back to the point. Physical activity accelerates this ATP renewal process. At rest, your brain and muscles use the most ATP. Your brain, though only 2% of your body weight, consumes up to 25% of your daily ATP. Neurons are firing constantly, and since they don't store ATP, they draw from your bloodstream without rest. So yes, writing this blog was exhausting. My brain used a tremendous amount of energy to do it. When you move, your skeletal muscles go into overdrive. Sprinting down the street, you're increasing ATP consumption in your muscles by over 100 times. Movement demands fuel. More movement means more ATP, and over time, your body adapts to this. An active person becomes more efficient. They generate more ATP per glucose molecule, they increase mitochondrial density in their cells, and they improve fat conversion for fuel. Their bodies clear lactic acid faster, and they resist fatigue longer because of it. Compare that to a sedentary lifestyle. Less movement means more reliance on inefficient anaerobic metabolism, faster fatigue, and lower mitochondrial density. The body struggles to maintain ATP production under strain. It's not just about fitness, it's actually about cellular function. And here's the most overlooked part: oxygen. Cellular respiration's full energy yield requires oxygen. Without it, you only get 2 ATP per glucose molecule. With it, you get up to 38. The waste products of this oxygen-powered process, carbon dioxide and water. It's what you breathe out and you eliminate by peeing. Ever wonder where the fat goes when you lose weight? You exhale most of it. Your fat is converted into energy, carbon dioxide, and water. You breathe your weight loss out into the air. So why is it so hard to lose weight? One major reason is your body's ATP demands. Your brain and muscles consume the most. If you want to burn more, you need to move more. And the more you move, the more efficient your cells become at producing and then using ATP. Physical activity isn't just about burning calories, it's about recharging the engine of life, making your cells stronger, your energy more sustainable, and your brain more capable. So next time you feel tired, sluggish, or stuck, remember, your body isn't asking for rest, it's asking for more movement. Even a little motion can light up your entire cellular world. Move more because your cells are begging you for it.